So we saw this shocking theorem. We also have a paradox and want of more discussion. But before getting to those things, I want to discuss a bit the history of this result. When was it discovered? I'd like to ask two specialists, if I show it, when do you think that people became to know about this theorem? Many people, quite some specialists, they know Debreu 1960, they know he gave necessary and sufficient condition for such a representation. But Debreu, he assumed complete separability, complete cell separability for matrices, so quite strong. And these conditions are quite weaker, so Debreu did not really have it. So then fewer specialists, but still quite a few, they know about Gorman 1968. Gorman, he published a very nice generalization of the Debreu theorem, and it can be seen if you have the Gorman theorem, and quite easily you can prove this theorem. So this is a corollary of Gorman 68. So then one might think, okay, so this was known since 1968, but that's still not historically right. You're off by 20 years even, because this result was published in 1948, mind you, way before Debreu, and it was in a paper by Nataf and Econometrica. It was written in French in those days, so many people nowadays will not be able to read. But anyway, he already had the result. He was interested in this question because he was interested in whether phenomena at the macro level can be considered to be integrations from phenomena at the micro level, whether these can be equivalent. That was the question he was studying. And he did it for a production process in a country. So let us assume there are producers in a country, maybe the individuals, but let us say factories, and there are production inputs in the country. And together they determine the production process in the country. Then how good is it? Well, one way to more micro-oriented will be that for every factory, you first evaluate how good the production process of that factory is, how good what they produce. Then those you aggregate over all the factories, then you get the total evaluation of the country. Now, question is, could you maybe do more integration at the macro level? Would it be possible that for every production input, immediately in one blow, you determine at the macro level how good they are? So you aggregate the columns first, and then all those values of the production input, you combine them together into the overall evaluation of how good the country is doing. That would be more a macro evaluation at that level. And when can they be equivalent? Probably you see if you do the first thing, if first you aggregate every factory, then you in fact have row monotonicity. And in the second case, if you can evaluate every production input on its own, then you have column separability. So these two can be equivalent, they both hold. Nataf showed, and you have seen it from the theorem, if and only if you have that additively decomposable representation, that means simply the whole is the sum of the parts. Well, that's a sort of a trivial, not so interesting case. Mostly the whole is more than just the sum of the parts. So in a way, it was a bit of a negative result that Nataf found. Only if there's not any interaction of any kind going on, can these things be equivalent. So in that sense, it was a negative result. But maybe you also see from this how general this, if you get results for aggregation over two or more components, and in many fields you have implications. And here's yet another example when it is a macro-micro aggregation. So that was the context when Nataf proved this result, but of course we can use it, it's a general result, we can use it everywhere. And in the rest of this lecture I want to show you that there's many dramatic implications for modern behavioral economics, this theorem of almost a century old. We're discussing quite a bit of that. First of all, Nataf explains or give better insights into what was going on in this paradoxical, the discounted expected utility theorem, at least mathematically what was going on. Because you may remember that when I presented the theorem, I presented to you as if innocent assumption that I called it act and stream monotonicity, but that meant in fact they imply row and column monotonicity. And now you know these conditions are not at all innocent. They are very strong. They have very strong implications. So now, I misled you maybe even a bit when I suggested that these conditions were self-evident and unobjectionable. They are very restrictive. They are dangerous. They have a seductive beauty in a way. They are misleading. So now you see better these conditions were very restrictive. You learned it from the Nataf theorem. And then we're already close to the discounted expected utility theorem if we apply Nataf. Not entirely yet, because Nataf has general additive representation for every function phi ij can depend on every row and column in any way you want. and the discounted expected utility theorem was a bit more restrictive. The functions were all proportional to each other. They were all a positive constant times the same utility function. But that last step is not very big. In fact, it's quite routine, because when I did the discounted expected utility theorem, those conditions act the stream monotonicity and logic monotonicity. They were not only implying a row separability for every row, but they were also implying, for instance, that for every side of the die, that the rows were ordered the same way. They also implied that. That's a bit stronger than just this monotonous row separability of the Nataf theorem. And then it's quite easy to see, and also the columns were also ordered all the same. Then it's quite easy to see that those additive value from phi ij must all be proportional to each other. Then the discounted expected utility theorem follows. So we will not discuss the details, but it's quite routine, small step. Essentially, you can say that this pretty theorem that I presented in the beginning was a corollary, almost immediate corollary of a theorem that had been known for almost a century already, of the Nataf theorem. That way we get better insight, at least mathematically, what was going on in that paradox. There was this strong, shocking Nataf theorem that brought it about. But, well, also we see from this, and I already said it, this monotonicity condition, they are not at all as innocent as first meets the eye. They are dangerous, they have many implications that you may not see very easily. So watch out for monotonicity. That's something that we have learned by now. But the Nataf theorem has many more, I might call dramatic implications for the behavioral approach. There is no middle ground in a way. So let's discuss that a bit more. That is the next section, section 3. But first I will reformulate the Nataf theorem, and then we'll see more what happens. I will give a quantitative reformulation. So that's the first thing. Now in quantitative evaluation, so before the Nataf theorem I gave preference conditions. Now I will give quantitative optimization formulations. Usually if you do quantitative evaluation of matrices, or multi-object, when there are multiple components to be optimized, you use recursive formulas for tractability reasons, because otherwise it's too complex, we don't know what to do. So usually we do a recursive formula. So let us look at them. And for instance, when we have now, let's assume two components, rows and columns, then either you first aggregate over the rows or you first aggregate over the columns, one of those two. That is what we can call row first. What you can do then is first you look at every row, you determine an evaluation of that row, some function R applied to it. That's abbreviated what comes out as R1. But I also add a superscript to the function R because I want to allow the row function to depend on the row. And for instance, if rows are different persons, of course, different persons have different utility functions over commodity balance. So this is a generality that we quite would like to have, and we do it in the general theorem. But anyway, so every row is evaluated first. We get m evaluations of the rows, and then we aggregate them into one overall evaluation using some, let me denote the capital function C. So that's how we do with a row first recursive evaluation. And I am assuming the usual thing that all these functions are strictly increasing and continuous, always the more the better, and continuity. Now it is quite easy to see that if you do this evaluation, then every row is separable, because every row, the ordering of the row is determined by the R function of that row, independent of what the level of the other rows is, because of the strict increasingness of the C function. You can see that that follows. It can also be seen that it's if and only if, that if you have separability of all the rows, then you can make a recursive evaluation row first. It's I will not you take my word for it now, but it's a standard result in consumer theory, so they are in fact equivalent. But we have already seen that this monotonicity condition is dangerous. There's more implication than first meets the eye. So if you first look at this row first evaluation, you think, oh, this is very general. We can have any function R that we like. It can be very nonlinear. Then we can take any C function as nonlinear and we like. So we have a lot of freedom, but still many things are already excluded by this, as we know. We have been warned by the Nataf theorem. Of course, you can also do column first evaluation. And then we get column monotonicity, the same kind of reasoning. And you now know already you can't have the two. If you have the two together, then all the interactions are excluded already. So it's more restricted than first meeting, and they're more competitive or excluding each other than people have been realizing so far, I think. But this could already have been learned from the Nataf theorem of almost a century old. Let me discuss a bit more, take stock of where we are for the behavioral approach. So in the behavioral approach, we would like to study interactions, fairness and regret and all these things. We would like to have, we want to have tractability, and tractability is at the level of the researcher, the modeler, who wants to have tractable models. That's a reason why researchers use recursive formulas. Otherwise, it's very hard to calculate or to do anything. That's a pragmatic argument. But also empirically, it's quite realistic that people are close to that. If a subject in an experiment must evaluate a matrix, it's quite natural at first the subject will look a bit at what the rows are and get some feeling about it, and then those feelings put together the overall feeling. Or maybe first look at the columns, and usually it's not completely some, there are some interaction, but not much. So I think also empirically it's realistic that data are either close to row first evaluation or to column first evaluation, one of those two. So for all kind of reasons, we're more or less committed to use one of these two recursive evaluations. So then let me draw a figure. So that's recursive. Let's go on. I draw a figure of the situation, and we have this shocking theorem that deprived us of from the middle ground. Now the left and the right end of the extremity, they are the same. We have no middle ground. So if we want to do anything behavioral, we have to give up at least one of the two weak separabilities. There's no other way. That's already a bit shocking, but then we have to live with it. And then for tractability reasons, we do either row monotonicity or column monotonicity, one of those two, and that's it. For tractability, you have to do one of these two. They are exclusive. You can't have both of them. It is really a bifurcation that we are facing. It's one or the other, and there's no clear alternative. Really bifurcation, and it's also quite critical, because now they are excluding each other. So if you choose one, you're throwing away at least half of the interactions that might be of interest. It's really a critical decision. Now that this is the case until about 10 or 15 years ago, very few people were aware of it. Many papers of those days were writing when they do optimization with, for instance, time and risk involved. They just write, let's assume the following evaluation. They wrote one of the two recursive formulas and then went on. No word, no discussion, they just went on. They were probably not so much aware how critical this is. Last 10 years, there have been more discussions of this, and even there have been experimental studies to see which of these two better fit the data. So there's more awareness. There has been a paper by Duyanet, Dillenberger, Otto Leva, and Gottlieb, I think, in Econometric 1920 about time lottery, so with time and risk involved. These authors already quite consciously discussed this issue. They choose the risk first evaluation, and they do this because they find it more convincing than the other evaluation, because separability is more convincing there. I'll say more about that later in this presentation. So these authors are already writing quite in the spirit of things that I'm saying now, but I don't think that anybody has been aware before that how critical that it's really a bifurcation, that there's no clear alternative, and it's one or the other. They are mutually exclusive, and whatever you choose, at least half of the possible interactions of interest you throw away. So the case is more acute, sharp than has been known before, what we show here, what you in fact can learn from the Nataf theorem. So therefore, you have to really think which of the two separabilities is more convincing. You have to discuss that if you want to apply this work. Our paper helps to make people more aware of it. Let me now give a few examples to show you how. So in a way, it's the $1 million question: row first or column first. Let me give you a few examples to show how critical this question is. Let us first assume we have welfare and risk. Those are the two components we're optimizing there. And here's a matrix, and here's another matrix. How do we think about those matrices? Well, in the classical theories with Harsanyi, utilitarianism, they are in the equivalent. It doesn't matter. But we like to do something behavioral. We like to consider the effect of inequality aversion. What will happen then? How do we think about the matrices then? Then $1 million question is row first or column first. So let me first do an evaluation where we do column, we assume column monotonicity. Then if you look upon it that way, Then you say there is fairness wherever you look, and everybody is equally well off in every situation. So these matrices are very indifferent to each other, because always both persons is 50-50 lottery, 1 or 0, and that's it. So complete fairness, they are completely indifferent, nothing happening. However, if you do row monotonicity, you look upon it that way, then you say in the left matrix, heads or tail, whatever comes up, there is inequality in that society. That's not nice. We have inequality aversion. We don't like the left matrix. The right matrix, heads or tails, whatever happened, there is equality. There is no inequality. We like the right matrix, but much better. So if you do this row monotonicity, then you say the right matrix is fairness, but the left matrix does not. So that's then you are not at all indifferent. So how it is with fairness in this situation? There is the $1,000,000 question: which form of integration do you choose? Another example, let's assume both components are uncertainty. There are ambiguous horses, whether they win the race, but there's a fair coin, 50-50 probability, heads or tails. And let us look at these two matrices. So if you do the classical expected utility with complete separability, like in the traditional Anscombe 63 paper, then you say they are just indifferent and all is the same, nothing happening. But we want to do something behavioral. We want to allow for ambiguity aversion, and then how should we evaluate these matrices? And then again, it's the $1,000,000 question. First, I look at column monotonicity. I look and I see for every horse in both matrices, always there results 50-50 lottery, 1 or 0. So it really doesn't matter. Both matrices are the same. And no matter which horse, it's always 50-50, nothing happening, no ambiguity. They are completely indifferent. By the way, this column monotonicity is usually assumed in the Anscombe framework. And I think it's more debatable than the literature is aware of for some people. If we do the row monotonicity, then we think quite differently. Let's first look at the right matrix. Then we say heads or tails, it doesn't, the horses actually don't matter at all. Ambiguity doesn't play any role. It's just heads or tail, 1-0. It's a 50-50 lottery. There's no ambiguity at all. We quite like that right matrix. If we look at the left matrix, then we say, no, wait a minute, heads or tails, whatever. There's always ambiguity. Both under heads and under tails, the outcome does depend on the horse. So we perceive a lot of ambiguity. We don't like it at all. Then you say ambiguity aversion is strong in the left, not the right. We strictly prefer the right to the left. But again, how you decide, how you evaluate, depends on the $1,000,000 question: row first or column first. And I think the Anscombe framework, without discussing much, maybe without even being aware of, is assuming the column first. But maybe I think there are reasons to think that row first is more plausible here. I think this is quite a problematic thing for the Anscombe framework. But anyway, we should see now how critical this question is. We have this bifurcation. It's really a critical question. So we should have diagnosis to see which of the two is more convincing, and we should find remedies if one is more useful for us than the other. Maybe if you are a social planner and you have to, or maybe your children, you have to divide ice creams over them. You want them to perceive fairness, then you maybe should frame it one way, not the other, to enhance maybe row monotonicity or column monotonicity, whatever serves the perception of fairness better. So those kind of things we should look into and discuss, and that will be in the next section, but in the next recording. So I finish this recording here.